Today we'll discuss ISI's MTech QROR 2016 MMA paper, and there are many questions and some of them are really good. Now the first question is, we are given this function f1x as x minus 2 square, and it says fn plus 1x is fn x minus 2 whole square. Let an and bn respectively denote the constant term and the coefficient of x in fn. Then we need to find what is an and bn. Now for f1x, we know that we can write it as x square minus 4x plus 4. Now what is f2x? f2x will be f1x minus 2 whole square. So it will be f1x, which is x square minus 4x plus 4 minus 2 whole square. So it will be x square minus 4x plus 2 whole square. So if we'll square it, we'll get x to the power 4 plus 16x square plus 4 minus 8x cube minus 16x plus 4x square. So we can write this as x to the power 4 minus 8x cube plus 20x square minus 16x plus 4. And the same way, if we write f3x, f3x will be f2x minus 2 whole square. So it will be x to the power 4 minus 8x cube plus 20x square minus 16x plus 2 whole square. Now here we'll not write the entire term. We'll just write coefficient of x and the constant term. Constant term obviously will be 2 square, that is 4. And then we'll get coefficient of x when this minus 16 gets multiplied with 2. So it'll be minus 64x. Now we look at the constant term here is 4, here also it is 4, here also it is 4. So for each of this f and x, this constant term will be 4. And what about coefficient of x? Coefficient of x for f1x is minus 4, here it is minus 16, here it is minus 64. That means constant term here is 4 and coefficient of x will be minus 4 to the power n, and that's your option number A. And actually I have solved this question previously in one of my previous videos. We have done that question using principle of mathematical induction. I'll provide the link to the proper solution to this question in the description below. Now question number 2 is, if a and b are positive real numbers whose sum is a constant lambda, then we need to find the minimum value of under root of 1 plus 1 upon a plus 1 plus 1 upon b. Now we know that we can write this expression E as under root of 1 plus 1 upon a plus 1 upon b plus 1 upon ab. Now we can also write this as 1 plus ab upon a plus b plus 1. Now value of a plus b is constant and that is lambda. So we can write this as 1 plus lambda plus 1 upon ab. Now in order to find minimum value of this expression, we have to find maximum value of ab. Now we know that arithmetic mean is always greater than equal to geometric mean. So we can write a plus b upon 2 is always greater than equal to under root ab. So from here we can write under root ab is always less than equal to lambda square by 4. Now we'll put the maximum value of ab here. We'll get minimum value of this expression. So minimum value of this expression will be under root of 1 plus lambda plus 1 upon lambda square, and here will be 4. So we can write this as under root of lambda square plus 4 lambda plus 4 upon lambda square, which is lambda plus 2 upon lambda. So it will be 1 plus 2 upon lambda, and there is no option like that. So that means answer to this question is none of the above. Now question number 3 is, let x be a positive real number, then which of the following option is correct? So what we'll do is, we'll take 3 pairs of numbers. One of them is x square plus pi square. We'll take their arithmetic mean, and arithmetic mean is always greater than or equal to their geometric mean. So that means this is always greater than equal to pi x. Now we'll take pi square and x to the power 2 pi. So am of pi square and x to the power 2 pi, it will be greater than equal to pi into x to the power pi. And now we'll take x square and x to the power 2 pi. So it is greater than x into x to the power pi. Now we'll add them. If we'll add them, then we can write x square plus pi square plus x to the power 2 pi, and it'll be strictly greater than, here it is pi x, and then we'll take x to the power pi common, and it'll be pi plus x. Now here we have taken this strict inequality sign because AM is equal to GM only when the numbers are same. So that means this x, it has to be equal to pi. But if x is equal to pi, then x square cannot be equal to x to the power 2 pi. So that means here these numbers, they cannot be same. So we'll use strict inequality in this case. So answer to this question is x square plus pi square plus x to the power 2 pi should be greater than pi x plus x into x to the power pi. And that's your option number A. Now question number 4 is, suppose in a competition 11 matches are to be played, each having one of the 3 distinct outcomes as possibilities. The number of ways in which we can predict the outcomes of all 11 matches such that exactly 6 of the predicted turns out to be correct. Now it says for 11 matches exactly 6 outcomes they are predicted. So that means we'll need to select which 6 out of 11. So that can be done 11C6 ways. Now for each of these 6 outcomes, we know that prediction is true. So that means there is only one possibility. Now for the remaining 5 matches, we know that there are 3 possible outcomes for each event. So that means if the prediction is not true, that means it can be either of the remaining 2 outcomes. So there will be simply 2 to the power 5. So answer to this question will be 11C6 into 2 to the power 5. And that's your option number A. Now question number 5 is, a set A contains 2n plus 1 elements. Now number of subsets of set which contains at most n elements is. So either it can have 0 elements, so it can have 2n plus 1 C0 elements, or 2n plus 1 C1 elements, and it goes up to 2n plus 1 and Cn elements. Now we need to find sum of this series. Now we know that 2n plus 1 C0 plus 2n plus 1 C1, 2n plus 1 Cn, 2n plus 1 Cn plus 1, and then 2n plus 1 C, 2n plus 1, it is equal to 2 to the power 2n plus 1. Now we know that NCR is same as NC n minus R. It means 2n plus 1 C, 2n plus 1 is same as 2n plus 1 C0. In the same way, just before that, it will be equal to C1. And this 2n plus 1 Cn plus 1 is same as 2n plus 1 Cn. So that means this series is symmetric about its middle term. So we can actually write this series as 2 into 2n plus 1 C0 plus 2n plus 1 C1, 2n plus 1 Cn, and it is equal to 2 to the power 2n plus 1. So we can cancel this 2. So answer to this series will be simply 2 to the power 2n, and that's your option number D. Now question number 6 is, a club with X members is organized into 4 committees such that each member is in exactly 2 committees and any 2 committees have exactly 1 member in common. We'll solve this problem using graph theory. So we'll take 4 nodes, and each of these nodes, they'll represent a committee. So we have 4 committees, say C1, C2, C3 and C4. Now it says each member is in exactly 1 committee and 2 committees share exactly 1 member in common. We have denoted committees with nodes. We'll denote members with edges. So each committee has exactly 1 member in common and each member is in exactly 2 committees. So we'll join all these numbers. Now this graph, it represents our condition that each member is in exactly 2 committees. So each member, it is connected by 2 nodes, and in between 2 nodes, there is exactly 1 edge. So that means total number of X will be 1, 2, 3, 4, 5 and 6. So the value of X is 6. So answer to this question is X has exactly 1 value and this lies between 4 and 8, and that's your option number B. Now question number 7 is, let X be a set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and define a set R, X, Y such that X and Y have the same remainder when divided by 3. So one of the possibility is when both the numbers they are same. So it is 1, 1 or 2, 2 or 10 and 10. So if all the numbers are same, then they leave the same remainder. So we have 10 cases here. Now when two numbers are not same, we can partition this set in three parts. One, the numbers which leaves the remainder 0, so they'll contain 3, 6, 9. Numbers that will leave the remainder 1, so there'll be 1, 4, 7 and 10. And then numbers that will leave the remainder 2, so it'll be 2, 5 and 8. Now we select any two from this set, they leave the same remainder, so it'll be simply 3C2. From this one, it'll be 4C2, and here again it'll be 3C2. Now this XY, it's an ordered pair, so that means elements that we have chosen, they can be arranged among themselves also. So it'll be 3C2 into factorial 2, it'll be 4C2 into factorial 2, and it'll be 3C2 into factorial 2. So number of elements in R, it will be 10 plus and then 3C2 plus 4C2 plus 3C2 into factorial 2. So it'll be 10 plus, now this is 3 plus 6 plus 3 into 2. So there'll be 12 into 2, 24. 24 plus 10 is 34. And that's your option number C. Now question number 8 is, let A be a set of n elements. The number of ways in which we can choose an ordered pair BC where B and C are disjoint subsets of A. So if B and C are disjoint subsets of A, that means for any element in A, there are three choices. Either this element will go to B, or it'll go to C, or it'll not go to either of B or C. So for the first element, we have three choices. Again, for the second one, we'll have three choices. For third, again, we'll have three choices. So in the same way, we'll have three choices for all the n elements. So the total number of ways in which we can choose these B and C will be 3 into 3 into 3 n times, and there'll be simply 3 to the power n, and that's your option number D. Now question number 9 is, let 1 plus x to the power n equals C0 plus C1x plus C2x square plus Cn x to the power n, where n being a positive integer, then we'll need to find the value of 1 plus C0 upon C1, 1 plus C1 upon C2, and 1 plus Cn minus 1 upon Cn. So we can write this expression as this product, which is 1 plus NCR minus 1 upon NCR, where the value of R varies from 1 to n. Now we know that NCR upon NCR minus 1 is n minus R plus 1 upon R. So we'll take LCM. We can write this as product R varies from 1 to n, and it'll be n plus 1 upon n plus 1 minus R. Now we'll put the value of R. We'll get n plus 1 upon n plus 1 upon n minus 1, n plus 1 upon n minus 2, and in the end we'll get n plus 1 upon 1. So it is nothing but n plus 1 to the power n, and this is 1 into 2 into 3 up to n, which is factorial n, and that's your option number D. Now question number 10 is, we need to find the value of this infinite product, which is 7 upon 9 into 26 upon 28 into 63 upon 65, and it is of the form n cube minus 1 upon n cube plus 1. So we can write this P as this product n cube minus 1 upon n cube plus 1, where the value of n varies from 2 to infinite. Now we can write this as this product, and this is a minus b, a square plus ab plus b square, and here it will be n plus 1, n square minus n plus 1. So what we'll do is we'll split this product in two parts. So first one will be n varies from 2 to infinite, n minus 1 upon n plus 1, and then this product, which is n varies from 2 to infinite, n square plus n plus 1 upon n square minus n plus 1. Now in the first product, if we'll put the value of n as 2, we'll get 1 upon 3, and then it'll be 2 upon 4, 3 upon 5, 4 upon 6. It'll continue, and the same way here we'll get 4 plus 2, 6, and this is 7, and this is 4 minus 2, 2 plus 1, 3. Now we'll put n as 3, it'll be 9, 10, 13, and here will be 9 minus 3, 6 plus 1, 7, and this series again will continue up to infinite. Now here this 3, 4, 5, 6, they'll all get cancelled, and here also this 7, 13 will get cancelled. So we'll get this result as simply 2 by 3. So value of this infinite product will be 2 by 3, and that's your option number B. Now question number 11 is number of positive integers which are less than or equal to 1000 and are divisible by none of 17, 19 and 23. So we'll find number of all the numbers which are divisible by either 17 or 19 or 23. So we'll get this number as n 17 number divisible by 17 plus number divisible by 19 number divisible by 23 minus numbers divisible by 17 into 19 19 into 23 minus numbers 17 into 23 plus numbers divisible by all three of them, 17 and 19 and 23. Now numbers divisible by 17 will be 1000 divided by 17, greatest integer function. Here will be greatest integer function 1000 divided by 19, greatest integer function divided by 23, 1000 divided by 17 into 19, 1000 divided by 19 into 23, 1000 divided by 17 into 23, and then plus 1000 divided by 17 into 19 into 23. Now this number is 58 plus 52 plus 43 minus 3 minus 2 minus 2, and then 1000 divided by 17, 19, 23, it is simply 0. So this number will be 146. Now number of positive integers which are divisible by none of these. So this number n will be 1000 minus 146. That is simply 854, and that's your option number A. Now question number 12 is consider a polynomial x to the power 5 plus ax to the power 4 plus bx cube plus cx square plus dx plus 4 where a, b, c, d are real numbers if 1 plus 2 iota and 3 minus 2 iota are two roots of this polynomial, then we'll need to find value of a. Now since a, b, c, d they are all real, we know that imaginary roots they occur in conjugate pair. So the other two roots will be 1 minus 2 iota and 3 plus 2 iota, and let the real root be alpha. Now we know that S5, which is product of all 5 roots, it will be alpha and then 1 plus 2 iota into 1 minus 2 iota, 3 minus 2 iota into 3 plus 2 iota, and there will be minus, and then it is 4 upon 1. So we'll get this as alpha, and this is 1 plus 4 is 5, and then 9 plus 4 is 13, and this is minus 4. So value of alpha is minus 4 upon 65. So its real root is minus 4 upon 65. Now we'll write S1, that is sum of all the roots. S1 will be alpha plus 1 plus 2 iota plus 1 minus 2 iota, 3 minus 2 iota plus 3 plus 2 iota, and it will be equal to minus a. Now value of alpha is minus 4 upon 65, and here 2 iota will cancel. So we'll get 6 and 2, 8. So plus 8, and this is equal to minus a. So it will be 520 minus 4. So that should be minus 516 upon 65. So answer to this question should be minus 516 upon 65. I do not know why they have given minus 524 upon 65. Answer should be minus 516 upon 65, and that is the answer to this question. Now question number 13 is we need to find number of real roots of the equation 2 cos x square plus x upon 6 is equal to 2 to the power x plus 2 to the power minus x. Here we have trigonometric expression on the left and exponential expression on the right. So generally in these questions we solve them using maximum and minimum values. Now we look at the left hand side, we know that left hand side is always less than or equal to 2 since the maximum value of cos x is 1. And if we look at right hand side, we know that am is always greater than or equal to its gm. So that means 2 to the power x plus 2 to the power minus x is always greater than or equal to 2. That means right hand side is always greater than or equal to 2. Now this equation can only have a solution when left hand side is 2 and when right hand side is also 2. Now we know that right hand side will be 2 when AM is equal to GM. And if AM is equal to GM, then both the numbers they'll be same. So 2 to the power x must be same as 2 to the power minus x. So that means from here we'll get the value of x as 0. So right hand side will be 2 when the value of x is 0. Now we need to find whether left hand side is 2 simultaneously for the same value of x. Now we'll put x as 0 here. We'll get 2 and then it'll be cos 0 and cos 0 is 1. So left hand side is also 2. So there is only one solution possible to this equation. So number of real roots of this equation is simply 1 and that's your option number B. Now question number 14 is consider the following system of equivalence of integers. X is congruent to 2 modulo 15 and x is congruent to 4 modulo 21. So that means x minus 2 is some multiple of 15 and also x minus 4 is some multiple of 21. From here, if we'll compare x, we can write 15m plus 2 is equal to 21n plus 4. So that is 15m minus 21n is equal to 2. Now here we can take 3 common. So we'll get 5m minus 7n is equal to 2. Now multiple of 3 cannot be equal to 2. So that means there is no solution to this equation. So number of solution x is simply 0 and that's your option number A. Now question number 15 is we need to find number of real solutions of the equation 9 upon 10 to the power x and it is equal to minus 3 plus x minus x square. Now again here we have exponential on the left hand side and a polynomial function on the right hand side. Again it is related to maxima or minima. Now if we look at left hand side is 0.9 to the power x and we know that any exponential function is always greater than 0. So this expression on the left hand side is always positive. Now if we look at expression on the right hand side, it is minus and then x square minus x plus 3. Now it is a quadratic expression opening downwards, and for this quadratic expression, if we look at the value of d is 1 minus 12 and which is less than 0. So a quadratic expression opening downwards and d less than 0, that means this quadratic expression will always lie below x-axis. So the value of y in this case will always be less than 0. So left hand side is always greater than 0 and right hand side is always less than 0. So that means there cannot be a real value of x for which left hand side is equal to right hand side. So number of real solutions in this case will be simply 0 and that's your option number B. Now question number 16 is if two real polynomials fx and gx of degree m greater than or equal to 2 and n greater than or equal to 1 respectively satisfy f x square plus 1 equals fx into gx, then we'll need to find condition on real roots of f. Now let us say suppose this fx has some real root, say alpha. So that means f alpha is 0. Now if f alpha is 0, then we can write f alpha square plus 1 equals f alpha into g alpha and it will be 0. So if alpha is one of the root, then alpha square plus 1 will be other root, and we know that alpha square plus 1 will always be greater than alpha. Now if alpha square plus 1 is root of fx, then if we'll put x as alpha square plus 1, we'll get f and then alpha square plus 1 whole square plus 1 equals f alpha square plus 1 into g alpha square plus 1. Now f alpha square plus 1 is 0. So that means another root will be alpha square plus 1 whole square plus 1. In this way, we'll get infinite roots. Now, any polynomial cannot have infinite roots. So that means there is a contradiction. So this fx can have no real root, and that's your option number D. Now, question number 17 is let x equals 1 upon 1001 plus 1 upon 1002 up to 1 upon 3001. So we can write this x as summation 1 upon n when the value of n, it varies from 1001 to 3001. This summation, which is 1 upon n when n varies from 1001 to 2001 will always be less than equal to this integral from 1001 to 3001 1 upon t dt, and always be greater than this integral from 1002 to 3002 1 upon t dt. Now we'll solve this integral, then this value, it will be log 3002 upon 1002 is less than this value x is less than equal to log 3001 upon 1001. Now this value, it is nearly 1.09728 is less than equal to x, and this is less than equal to 1.0979. So this value, it lies between 1 and 1.5, and that's your option number C. Now question number 18 is, the set of complex numbers represented by this equation 3 plus 7 iota z plus 10 minus 2 iota z bar plus 100 equals to 0 represents what? So we can write z as x plus iota y. We can write 3 plus 7 iota into x plus iota y plus 10 minus 2 iota into x plus iota y and plus 100 equals to 0. Now we'll take the real part. Its real part will be 3x minus 7y, and here it will be 10x plus 2y plus 100, and then its imaginary part will be 7x plus 3y plus 10y minus 2x equals 0. So we'll get this condition as 13x minus 5y plus 100 plus iota 5x plus 13y equals 0. So the condition will be 3x minus 5y plus 100 equals 0, and then 5x plus 13y equals to 0. Now these two conditions, they must be simultaneously true. So that means if we'll solve these two equations, which are two linear equations, we'll get a point. So answer to this question will be the set of complex number z satisfying this equation will be a point, and that's your option number C. Now question number 19 is, we'll need to find this limit, which is limit n tends to infinite, then summation k varies from 1 to n, and this is e to the power 2 pi by n into iota k minus e to the power 2 pi iota k minus 1 upon n. Now for the sake of brevity, we'll write 2 pi by n as some theta. So we can write this as summation e to the power iota k theta minus e to the power iota k minus 1 theta. And this summation, it varies from 1 to n, where limit n tends to infinite. Now here we'll take e to the power iota k minus 1 theta common. So we'll take it common. We can write limit n tends to infinite summation k varies from 1 to n, and then mod of e to the power iota k minus 1 theta, and then e to the power iota theta minus 1. Now modulus of e to the power iota theta is simply 1. So this value will be 1. So we can write this as limit n tends to infinite, and then summation k varies from 1 to n mod of e to the power iota theta minus 1. Now this expression, it is independent of k. So it will actually be limit n tends to infinite n into mod of e to the power iota theta minus 1. Now we'll put the value of theta. Theta is 2 pi by n. So we can write this limit as limit n tends to infinite e to the power 2 pi by n iota minus 1, and this mod upon 1 by n. Now we'll multiply and divide it with mod of 2 pi iota. So this limit, it is standard limit e to the power x minus 1 upon x, which is 1, and then mod of 2 pi iota is simply 2 pi. So answer to this limit is simply 2 pi, and that's your option number C. Now question number 20 is, we need to find this limit, which is limit n tends to infinite 1 minus 1 upon n square to the power n. Now form of this limit is 1 to the power infinite, and if the limit is of the form 1 to the power infinite, we can use the direct shortcut, and which is limit x tends to a fx to the power gx. If it is of the form 1 to the power infinite, we can write this as e to the power limit x tends to a gx into fx minus 1. So we'll use the same shortcut here. So it'll be limit n tends to infinite e to the power, now gx is n, and then fx minus 1. So 1 minus 1 upon n square minus 1 will be simply 1 minus n square. So here n and n will cancel. So we'll get limit n tends to infinite e to the power minus 1 by n. Now this is e to the power 0, and e to the power 0 is 1, and that's your option number D. Question number 21 is, let omega denote a complex fifth root of unity, then define bk as this summation j varies from 0 to 4 j into omega to the power minus kj. Now we can write this bk as 0 into omega to the power 0 plus 1 into omega to the power minus k, 2 into omega to the power minus 2k, plus 3 into omega to the power minus 3k, plus 4 into omega to the power minus 4k. Now we need to find this summation, which is summation k varies from 0 to 4 bk into omega k. Now bk into omega k, it will be 1 plus 2 into omega to the power minus k, 3 into omega to the power minus 2k, and 4 omega to the power minus 3k. Now we'll need to find this summation. So this summation will be k varies from 0 to 4 bk omega to the power k. Now this is summation 1, 2 into summation omega to the power minus k, 3 into summation omega to the power minus 2k, and 4 into summation omega to the power minus 3k. Now summation 1, it is 5. Now what about summation omega to the power minus k? It is nothing but a geometric progression. So its sum will be a, and then 1 minus omega to the power minus 5k upon 1 minus omega to the power minus k. In the same way, second one will be 1 minus omega to the power minus 10k upon 1 minus omega to the power minus 2, and then plus 4 into 1 minus omega to the power minus 15k upon 1 minus omega to the power minus 3. Now we know that omega is fifth root of unity. So that means omega to the power minus 5k, it will always be 1. So any power of omega which is multiple of 5 will always be 1. So here 1 minus 1 will be 0. This one will also be 0, and this one is also 0. So that means the value of this summation is nothing but 5, and that's your option number A. Now question number 22 is, we are given this an, which is 1 minus 1 upon root 2, 1 minus 1 upon root 3 up to 1 minus 1 upon root n plus 1. We need to find this limit n tends to infinite an. Now we know that one minus 1 upon root 2 is less than 1 upon 1 minus root 3 is less than 1 upon 1 minus root 4, and will be less than 1 upon 1 minus under root of n plus 1. Now we know that all the terms, they are greater than 1 minus 1 upon root 2. So if we'll replace all the terms in the product with 1 minus 1 upon root 2, we can say that an is always greater than 1 minus 1 upon root 2 to the power n. It will always be less than its maximum value. Maximum value is 1 minus 1 upon under root n plus 1, and then again n times. Now we'll take this limit, which is limit n tends to infinite. Now this expression, it is less than 1. Now when a is less than 1, then a to the power infinite is simply 0. Now what about this right hand limit? This right hand side limit, it is of the form 1 to the power infinite. So again we'll use shortcut. So it'll be e to the power limit n tends to infinite, and then n and fx minus 1 will be under root of n plus 1. So this value, it will be e to the power minus infinite, which again is 0. So this limit on the left, it is 0, and this limit on the right is also 0. Then from sandwich theorem, we can say that this limit n tends to infinite, an, it will be 0, and that's your option number D. Now question number 23 is, let X be a non-empty set and let Px denote collection of all subsets of X. Define F from X to Pa to R by Fxa is 1 if X belongs to A, and it is 0 if X doesn't belong to A. Now what about Fx A union B? Now we know that Fx A union B will be Fxa plus Fxb minus Fx A intersection B. So it will be simply Fxa plus Fxb. Now we need to subtract this case when this X is present in both A and B. So when X is present in both A and B, we can write this as simply Fxa into Fxb. Now if X is present in both A and B, then this value will be simply 1. And if it is not present in both, then in that case, this expression will always be 0. So that means Fx A union B will be Fxa plus Fxb minus Fxa into Fxb, and that's your option number C. Now question number 24 is, the series converges to which expression? So we know that this is telescopic summation. We can write this as k varies from 2 to infinite, and this is 1 upon k minus 1 minus 1 upon k. So it will be k minus 1. So we'll take k as 2. We'll get this as 1 minus 1 upon 2. If we'll take k as 3, we'll get 1 upon 2 minus 1 upon 3. And then 1 upon 3 minus 1 upon 4. It will continue up to infinite. All these successive terms, they'll cancel. So answer to this series will be 1. So this series converges to 1, and that's your option number B. Now question number 25. Again it is 1 to the power infinite form. So we'll use shortcut. So it'll be e to the power, then limit x tends to infinite, and then gx, which is 4x, and fx minus 1. So it'll be 3x minus 1 upon 3x plus 1 minus 1. So we'll get this as limit x tends to infinite, and here it will be minus 8x upon 3x plus 1. Now this is an infinite limit. Highest power is x. So this limit will be e to the power minus 8 by 3, and that's your option number C. Now question number 26, it is nothing but limit of sum. So we can write this as summation 1 by n, and then n upon n plus r, where r varies from 1 to n. So we can write this as summation r varies from 1 to n, 1 by n, and this is 1 upon 1 plus r by n. Now we'll replace this summation with integral sign. Now we'll replace r by n with x. So it'll be 1 upon 1 plus x, and 1 by n is nothing but dx. Now limits, when r is 1, it is 1 by n, which is 0, and then n upon n, it is 1. So it'll be simply log 1 plus x from 0 to 1, which is nothing but log 2. So the value of this limit is log 2, and that's your option number C. Now question number 27 is, we need to express cos to the power 6 theta in terms of 6 theta, 5 theta, 4 theta, 3 theta, 2 theta, theta, and constant term. We need to find this constant term. Now we know that we can write cos to the power 6 theta as 1 by 16 4 cos cube theta whole square. Now 4 cos cube theta is cos 3 theta plus 3 cos theta whole square. So we can write this as 1 by 16, and it'll be cos square 3 theta plus 9 cos square theta plus 3 into 2 cos 3 theta into cos theta. Now we'll multiply and divide it with 2 also. So we'll multiply it with 2 and divide it with 2. So we'll get this as 1 upon 32. Now 2 cos square 3 theta is 1 plus cos 6 theta, and here it will be 9 1 plus cos 2 theta Here it will be 6 and then 2 cos A cos B, cos A plus B plus cos A minus B. Now we need to find its constant term. Its constant term will be 1 upon 32 and then this is 1 plus 9. So it will be simply 10 by 32 and that's your option number D. Now question number 28 is, in a triangle ABC, AD is the median. So we have this triangle ABC and then AD is the median. We need to find length of AD. Now from Apollonius theorem, we know that AB square plus AC square, it is 2 times AD square plus CD square. Now what's AB square? AB square is 7 square and AC square is 15 square and it will be 2 times AD square we need to find and then CD square. CD is half of BC, so it will be simply 5 square. So it will be 225 plus 49, which is 274. 274 divided by 2 is 137. So AD square will be 137 minus 25, which is 112. So value of AD is simply under root of 112 and that's your option number C. Now question number 29 is, x plus 1 upon x greater than 6, it equals to which of the following set? Now we know that mod of x plus 1 upon x is greater than 6. It is equivalent to x plus 1 upon x when it is less than or equal to minus 6 or x plus 1 upon x when it is greater than 6. So we can write this as x square plus 6x plus 1 upon x and it is less than 0. Now the roots are 0 and then minus 6 plus minus 36 minus 4. So it will be 32 divided by 2. So it will be minus 3 plus minus 2 root 2. So the 3 roots will be minus 3 minus 2 root 2 and then minus 3 plus 2 root 2 and then it is 0. Now rightmost it is plus. So plus minus, plus and minus, we need minus. So it is either less than minus 3 minus 2 root 2 or it is between minus 3 plus 2 root 2 and 0. Now we'll solve this second case. Now for this second case, we'll get x square minus 6x plus 1 upon x. It is greater than 0. So it will be x equals 0 and then 6 plus minus under root 32 upon 2. So it will be 0 and then 3 plus minus 2 root 2. So now we can write 0, 3 minus 2 root 2, 3 plus 2 root 2. Now rightmost is plus, so it is plus, minus, plus and minus. Now in this case, we need plus greater than 0. So answer to this question will be x belongs to from minus infinite to minus 3 minus 2 root 2 union minus 3 plus 2 root 2 to 0 union 0 to 3 minus 2 root 2 union 3 plus 2 root 2 up to infinite. Now there is no option like this in this question. They have given this option but then 0 is included in this option. Now we know that x cannot take a value 0. So that means none of the option matches for this question. Now question number 30 is, suppose a function is defined by the following condition, which is fx plus ty, it is equal to fxy plus ty, fx comma t plus y is equal to fxy plus tx, and f00 is equal to k, a constant. Fxy is equal to which of the following value? Now we'll put x and y as 0, we'll get ft comma 0 as f00, which is k, and we'll get f0 comma t as again f00, which is again k. Now in this second equation, if we'll put y as 0, we'll get f xt as f x0 plus tx. Now if we'll replace t with y, we'll get f xy. Now what is fx0? Fx0 is simply k, so it'll be k and then plus xy. So answer to this question is option number C.